Hi guys, welcome back to our channel. Today we are going to learn about basic graph sketching and graph transformation. Before we start, you need to learn about the characteristics of each of the parent graph, which are commonly studied in mathematics. Now let's look at the first parent graph. This is a linear graph of y equals to x. It is a straight line graph which passes through point 0, 0. The domain for y equals to x can be written as x, such that x consists of all sets of real numbers. Meanwhile, range can be written as y, such that y consists of all sets of real numbers. You can also write the domain and range in the form of interval notation, from negative infinity to positive infinity. This is a parent graph of an absolute value or modulus function. It is a V-shaped graph with a vertex at the point 0, 0. The domain is x consists of all sets of real numbers. Meanwhile, the range is y greater or equals to 0. This is a quadratic graph of y equals to x squared. It is a parabola, or it can be described as a U-shaped graph. It has a vertex at point 0, 0. So the domain will be x consists of all sets of real numbers. Meanwhile, the range will be y greater or equals to 0. This is a square root graph. It is actually half of a parabola lying on its side. It has a vertex at point 0, 0. So the domain will be x greater or equals to 0. Meanwhile, the range will be y greater or equals to 0. This is a parent graph of a cubic function. It is a curve with an inflection point at 0, 0. This is a point where the graph changes its direction. So the domain and range will be all sets of real numbers. This is a reciprocal graph or a hyperbola. Notice it has two asymptotes, horizontal and vertical asymptotes. Asymptote is a straight line where the graph approaches and eventually follows alongside, but it does not meet at any definite point. When x approaches negative infinity or positive infinity, y will be approaching 0. When x approaching 0, y will be approaching positive or negative infinity. So the domain will be x consists of all sets of real numbers except x equals to 0. Meanwhile, the range will be y consists of all sets of real numbers except y equals to 0. This is an exponential graph for the function y equals to a to the power of x, where a is greater than 1. We may often find the constant e in mathematics. E stands for Euler's number, which is equals to 2.71828, and so on. You will learn more about Euler's number in the topic index and logarithm. Now let's focus on this graph. When x is approaching negative infinity, y will be approaching 0. When x is approaching positive infinity, y will be also approaching positive infinity. Therefore, this graph has a horizontal asymptote of y equals to 0. Notice this graph has a y-intercept at point 0, 1. This is because when any constant greater than 1 is raised to the power of 0, you will always get 1. So the domain for this graph will be x consists of all sets of real numbers. Meanwhile, the range will be y is greater than 0. This is a parent graph for the function y equals to log base a of x, where a is greater than 1. Log base e of x is also called natural log of x. Notice this graph has an x-intercept of 1, 0. It has also a vertical asymptote at x equals to 0. So the domain for this graph is x greater than 0. Meanwhile, the range is y consists of all sets of real numbers. This is a sine graph, which is one of the trigonometric graph. You will learn more about this graph when you go to the topic trigonometry. Notice it has a sine wave. The range for this graph is from -1 to 1. This is a cosine graph. It has a sinusoidal wave just like the sine graph. If you look closely, it is different from the sine graph because it starts at the level 1 when x equals to 0. The range for cosine graph is also from -1 to 1. This is a tangent graph. Notice it has a repeated vertical asymptotes at pi divided by 2 plus n pi. Okay guys, let's move on to graph transformation. Let's look at the first transformation, vertical translation. When we write f of x plus 1, it means the graph will move up by 1 unit. If we write f of x minus 1, it means the graph will move down by 1 unit. Let's look at this example. Now let's look at the second transformation, the horizontal translation. When we write f of x plus 2, it means this graph will shift to the left by 2 units. If we write f of x minus 2, it means this graph will shift to the right by 2 units. Let's look at these examples. Now let's look at the third one. When we write negative f of x, it means the graph will be reflected over the x-axis. If we write f of negative x, it means the graph will be reflected over the y-axis. Let's look at these examples. Now let's look at the fourth transformation, a f of x. When a is greater than 1, for example 2 f of x, the graph will be vertically stretched. When a is between 0 and 1, for example half f of x, the graph will be vertically compressed. Let's look at these examples. Now let's look at the fifth transformation, f of ax. When a is greater than 1, for example, f of 2x, this graph will be horizontally compressed. When a is between 0 and 1, for example, f of half x, this graph will be horizontally stretched. Let's look at these examples. Now let's go to the final graph transformation, modulus f of x versus f of modulus x. For the graph modulus f of x, it means the negative part of this graph will be reflected upwards over the x-axis. For the graph f of modulus x, first you need to ignore the left side of the parent graph. Subsequently, you will reflect the positive part of the parent graph over the y-axis. This is the summary of the graph transformation rules. Now let's try this question. You are given a parent graph with specific coordinates and 3 different types of graph transformation. You are required to sketch each of these graphs and state the new coordinates. Now let's look at this example. You are given f of x with a coordinate a, 0, 0. Find the new coordinate and sketch the graph when the function undergoes transformation 1 minus 2 multiply f of 1 minus half x. If you look closely, 1 minus 2 multiply f of 1 minus half x actually consists of 6 different types of graph transformation. The blue part will affect the x coordinate. Meanwhile, the red part will affect the y coordinate. First, you need to start with the horizontal translation, then reflection over y-axis. After that, horizontal stretch or compression. Subsequently, you will do the vertical stretch or compression, then reflection over x-axis, and finally vertical translation. Now let's look at how this graph transforms step by step. In this chapter, we will learn how to sketch a square root, reciprocal, exponential, and logarithmic graph. For linear, quadratic, cubic, and modulus graph, you will learn all these graphs separately in each topic. Let's look at this question. Sketch the graph y equals to square root of 2x plus 1 minus 2, then determine the domain and range of this function. To sketch this graph, all you need to do is just follow 4 simple steps. Step 1. Determine the final shape of this graph. You need to ask yourself 2 questions. What is the parent graph? And does this graph involve any reflection over y or x-axis? As we know, this is a square root graph. And for this function, this graph does not involve any reflection over y or x-axis. So this will be the final shape of this graph. Step 2. Determine the important point or asymptote. Since this is a square root graph, we need to find the vertex. To find vertex, you need to let the square root part, which is 2x plus 1, equals to 0. So your vertex will be -half, -2. Step 3. Determine y or x-intercept. You must be careful. Some of the function may not have any y or x-intercept at all. For this function, to find y-intercept, let x equals to 0. So your y-intercept is 0, -1. So step 4. Sketch the graph and determine the domain and range. This is how the graph looks like. Domain of this function is x greater or equals to -half. Range is y is equal or greater than -2. Now guys, let's try this question using the same technique that I have taught you just now. To sketch this graph, y equals to 1 over 1 minus 2x. Step 1. This is a reciprocal graph. This function involves a reflection over the y-axis. Step 2. We must find the vertical and horizontal asymptote. To find vertical asymptote, you must let the denominator part, which is 1 minus 2x, equals to 0. So x equals to half. When x is approaching infinity, 1 over 1 minus 2x approaching 0. So your horizontal asymptote is y equals to 0. Step 3. To find y-intercept, let x equals to 0. So y-intercept is 0, 1. This is how the graph looks like. The domain will be x consists of all real numbers except x equals to half. And range will be y consists of all real numbers except y equals to 0. To sketch this graph, y equals to x minus 2 divided by x minus 1. First, you need to expand this equation so that the numerator part will be a constant. You will get this final form, y equals to 1 minus 1 divided by x minus 1. It will be easier for you to find the vertical asymptote and horizontal asymptote. Use the same technique as I mentioned to you earlier to sketch this graph. To sketch this graph, y equals to 1 minus 2e to the power of x. Step 1. This is an exponential graph. This graph involves a reflection over the x-axis. Step 2. To find horizontal asymptote, when x is approaching negative infinity, e to the power of x approaching 0. So y equals to 1 is your horizontal asymptote. Step 3. Your y-intercept is 0, -1. X-intercept is -0.690. This is how the graph looks like. The domain will be x consists of all sets of real number. range is y less than 1. Now you can try this question using the same technique. That's all for today. Thank you for watching. I'll see you in the next video. Bye.